one thing is like with these are called terminal posts, and the physical connection, if these aren't really tight, if you don't have a real solid connection, and you were to come up here and like jostle these around, you could kind of disrupt the voltage signal or whatever, trap the circuit, and so the gauge might no longer be reading 0.
Okay.
So I don't know. I like to see like these all seem pretty tight. Like I like to see that. You know, in theory, if you have all real good tight connections, you could like move this box around and disturb it, and like it'd be fine. But if you find, I've seen that before, where like we'll have one of these maybe on the floor, and like someone will kick it, and like all the strain values will like jump up and down or something. It's like, well, that's not good. So you'd want to like, it's just something to make sure, like, you know, you need good tight connection.
Okay.
But so let's try to find one. So something I made is, maybe I did put these on there, but I used that spreadsheet we were just looking at to make these labels.
So you have the channel, and then you also have the name.
Yeah. So we talked about hooking up strain gauges to the module and terminal that's capable of connecting 24 instruments at a time. So 3 of these are 8 channels.
Okay.
And so 3 of these black boxes make up one bundle that connect to, I think it's a 1317 terminal. So like it looks like this is module 5, module 5.
This one looks like it's...
Oh yeah, module 5, yeah. So these 3 boxes are all bundled into one, and then I plug them into chassis 1. In each of these channels, they start at 0. So that's 0 through 7, then this guy's 8 through 15, and this guy's 16 through 23.
Okay.
So because we start at 0, these are 24 channels. So I assign each instrument to a channel, then I print out this label, put the label on each of these boxes, so now it's real easy for me to take, instrument W2, and I just look for where I've printed out the label W2, and I just connect it right there.
Okay. So these are put on when the strain gauges are put on the steel, and they're like pulled up through before they pour concrete.
Yeah. So some of the cables aren't long enough. So the cables, they're like 5-meter cables. Yeah, like 3 meters. Maybe they're 3 meters. Forget how long. But basically, some of the gauges that are way down at the bottom, the cable traveling all the way up, it's not long enough. So we extend it with an extension that is kind of, you can't see it, but it's within this duct tape. But we literally we have extra wire like this. I mean, you can see that this wire is coming out of this concrete, and it's only this long. So we soldered on, another couple feet of wire so that we can easily make the connection to wherever it's getting connected up here, right? And this is nothing more than we just soldered blue to blue, and then, it doesn't really matter which gray wires we soldered to each gray wire. But so this is V2. So I'd like to think that, if I were to track this wire all the way down, it's connected to V2 on here. But alright, so which one? Let's find one that's not
C5.
Alright, so let's try to find. They should be kind of grouped. Okay, C.
There's some C's right here. C4, C5 is right here.
It doesn't even, does it have anything connected?
Yeah, there's something in it.
There is?
It's not very tight though. It was these 3.
Okay.
So we need
Alright, so C5, yeah, so it's connected. The first thing to look at is the blue wire connected to the red post?
Okay.
Because the blue wire has to be connected to the red post. The other two gray wires, it doesn't matter whether they're connected to the black or the yellow.
Okay.
But it's the red wire needs to be connected. Excuse me, the blue wire needs to be connected to the red post. So, I've seen it where, when you're doing this late at night and you've connected, 100 of them, it's pretty easy to screw up one.
Yeah.
And that could be the source of the error. Just,
so just check to make sure
yeah.
the right wire.
So because we actually have this connected properly, I'm going to disconnect it and we're going to connect it up to that box.
Maybe she's not a heights person.
Huh?
Maybe she's not a heights person.
Yeah. One thing too about connecting these, you always want to, there's a little hole.
I think you have to slide it through.
You want to put it through the hole and not just kind of clamp it down on the side. That's just good practice. So first thing, this is kind of nice to see, oh yeah, we did connect, C5, tag C5 to the channel I denoted as C5. Alright, so one thing about these alligator clips, you can just put this on. A reason you want to make sure you tighten these, because these things will get jostled around.
Okay.
So we're going to connect red to blue.
So let's see this thing.
Up and see, look, I made a mistake. This is the blue wire. I think mine's around. Let's just do this. So, show you how to do it. Alright, so let's turn this guy on. I like to check your amps here. That's good.
Now we're
Gauge factor is fine. Alright,
Yep.
so yeah, it doesn't work, but it definitely doesn't work because I connected it to the wrong. I didn't connect red to blue. Alright, and so here's.
Now it's all over the place.
Yeah, alright, so this is good. This is an example where it was bouncing all over the place. It's kind of being a little funky. Now,
Because now it's
pretty
pretty
stable.
good.
Yeah, even if this number was 2,000 or something, it doesn't matter. It's a stable reading. So I think this is good. Now it'd be nice if you could actually strain the bar a little bit, kind of like when we were down there. We could just kind of bend the piece of aluminum to see, all right, is it going negative when I put compression on it, or positive when I put tension on it? But we don't have that luxury. So what I can assume from that this may be the case where the instrument is working properly, but we have it connected to this channel, and this channel is faulty. And so something that could be wrong, we made these ourselves, right? These black boxes in-house. So the wire, something with the wire that goes from here all the way into that terminal, we could have a faulty, one of those wires could be cut. They could be, at one point in time, these were all tested, so they in theory should all be working.
Mm-hmm.
But they can definitely just degrade over time. They get a lot of use, people, whatever, picking them up, putting them down, moving them around, connecting a lot of different instruments, stepping on them and stuff. So rather than trying to troubleshoot why this channel isn't working, there's usually enough empty slots that we can just put this C5 somewhere else in, you know, into an empty channel that hopefully will work. So let's try to find
So
something.
usually it's like blank on the front. In
But
that spot,
blank
empty.
or a spot where, you know, we just
Maybe
never,
we'll miss some tags.
huh?
Maybe
Yeah,
we'll
like
just
a-
take this off so we can see.
Yeah.
Or this way.
So usually I try to find a spot that's like kind of close to where this instrument is. Even if we found one way down there, it'd probably be difficult to get this wire over there. Because that might be what we have to do. Maybe we have a real...
That's all full.
There should be, unless we had the exact amount, there should be like one box maybe that has a handful of them. Yeah, this guy's empty. This goes way down here. Another thing to be careful of is, yeah.
Which one did you find?